Sum and difference formulas. Sum and difference formulas, or sum and difference identities, are very useful within trigonometry. So far, what we've seen in trigonometry, we can find the exact value for angles of 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and multiples of those. We've also been able to find exact trigonometric values for values of pi over 4, pi over 3, pi over 6, pi over 2, etc. But we were limited to only those angles. And we were limited because those are the ones that have special right triangles associated with them. However, sum and difference formulas allow us to find exact values for some other angles, and we're going to look at that today. When we look at these equations here, there's two equations written in one, essentially to save space. I've written them out here for you. Cosine of A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. If you notice, the top sign in the parentheses here goes with the top sign over here. So when we're adding within the cosine, the equation has a minus sign. When we're subtracting within the cosine, the expanded equation has a plus sign. The same thing happens with sine and tangent. I've written them out here for you so you can see them fully written. Let's move into an example. Example 1 says to find the exact value of the cosine of 75 degrees. 75 degrees is not one that we have been able to find an exact value for in previous lessons. However, 75 degrees is the sum of 30 degrees and 45 degrees, since 30 plus 45 gives us 75. As a result, we have the ability to say that we want to find the cosine of 30 degrees plus 45 degrees. And we can use our cosine sum formula. And that cosine sum formula will then allow us to find this exact value. The cosine sum tells us that we need to take the cosine of the first angle, which is 30 degrees, times the cosine of the second angle, 45 degrees, minus the sine of the first angle times the sine of the second angle. Now, if we look at these individual cosine and sines, we have an ability to find the cosine or sine of those values. We've done that often. The cosine of 75 degrees is going to be equal to the cosine of 30. Well, let's go to our unit circle. And the cosine of 30 degrees, cosine is x, well, that happens to be the square root of 3 over 2. I'm going to replace the cosine of 30 with the square root of 3 over 2. The cosine of 45 degrees. The cosine of 45 degrees is the square root of 2 over 2. Replace cosine of 45 with the square root of 2 over 2. The sine of 30 degrees. Sine is your y value. Here it is 1/2. We have 1/2 times the sine of 45. The sine of 45 is also the square root of 2 over 2. All I used was this formula up here and applied and then found each of the exact values for the different components. Let's simplify. The cosine of 75 degrees is going to be equal to, when we multiply fractions, we multiply top times top and bottom times bottom. When you're multiplying roots, you keep the root and multiply together what's on the inside. 3 times 2 leaves us with 6, and we keep the square root. 2 times 2 is 4. Minus 1 times the square root of 2 leaves us with the square root of 2, divided by 2 times 2 is 4. And now we have to subtract these fractions. In order to subtract fractions, we have to have a common denominator, which we do in fact have a common denominator here. That leaves us with the cosine of 75 degrees is equal to the square root of 6 minus the square root of 2, all divided by 4. And that is going to be our final answer. Example number 2. Here we want to find the exact value of the cosine of pi over 12. Since we are more fond of working with degrees, let's determine pi over 12 is equivalent to 15 degrees. We need to find the exact value of 15 degrees. We need to think of two angles that, when added or subtracted, would give us 15. So 45 degrees, if we subtract 30 degrees, it leaves us with 15 degrees. Since this is in radians, I'm going to complete it in radians. 45 degrees is pi over 4. 30 degrees is pi over 6. And then this is a cosine also, just like we did in the previous problem. However, this time we are going to subtract. So if we look up here at the top of the page, cosine of a minus b will be equal to the cosine of a times the cosine of b plus the sine of a times the sine of b. The cosine of pi over 4 minus pi over 6 is equal to the cosine of pi over 4 times the cosine of pi over 6 plus the sine of pi over 4 times the sine of pi over 6. Now we have to use our unit circle and evaluate each of those. Cosine of pi over 4 we saw earlier, cosine of pi over 4 was square root of 2 over 2. And the cosine of pi over 6, cosine of pi over 6, the x is the square root of 3 over 2. Plus the sine of pi over 4, which is the square root of 2 over 2, times the sine of pi over 6, which happens to be 1/2. Now all we have to do is multiply and add, fully simplify. Cosine of pi over 12 is equivalent to the square root of 2 times the square root of 3 is the square root of 6 divided by 4 plus the square root of 2 times 1 leaves us with the square root of 2 divided by 4. And if we add, the cosine of pi over 12 results in the square root of 6 plus the square root of 2 all divided by 4. Some of you might wonder, couldn't we simplify these since there's a 2 in all of them? But since the ones in the top are in radicals or in roots and the one in the bottom is not, we do not have the ability to simplify. So we have to leave this as the square root of 6 plus the square root of 2 all divided by 4. Example number 3. Example number 3 says to find the exact value of the sine of 7 pi over 12. 7 pi over 12 happens to be equal to 105 degrees. you have the ability to determine whether you want to use a sum or a difference for this one. In the previous problem, in example 2, to find 15 degrees, there was nothing that we could add together to get to 15 degrees. However, here, we could add 60 and 45 to get 105 degrees, or we could also subtract. So you kind of have to decide what you want to do. We could have done 150 minus 45 degrees. I'm going to add, but you would get the same exact answer if you subtracted. So let's use 60 plus 45. Well, 60 happens to be pi over 3, and 45 is pi over 4. This time we're looking at a sign. So the sign of pi over 3 plus pi over 4. If we look back at the top of our page, the sine of a plus b equals the sine of a times the cosine of b plus the cosine of a times the sine of b. Down here, we will end up with the sine of pi over 3 times the cosine of pi over 4 plus the cosine of pi over 3 times the sine of pi over 4. Now we're going to have to evaluate. From our unit circle, sine is y. At pi over 3, our y value is the square root of 3 over 2. The cosine of pi over 4 hasn't changed from the last two problems. It's the square root of 2 over 2. The cosine of pi over 3, our x value at pi over 3 is 1/2. And the sine of pi over 4 is the square root of 3 over 2. Now we multiply and simplify. Here we get the square root of 6 divided by 4 plus the square root of 3 divided by 4. Add those fractions together. The sine of 7 pi over 12 is equal to the square root of 6 plus the square root of 3, all divided by 4. Oops. Error. That should be the square root of 2.